Thank you very much for inviting me. I'm very happy to be here and always excited to talk about the resources that we have available at High Performance Research Computing. My name is Lisa Perez. For those that don't know me, I'm the director for the Advanced Computing Enablement Group, otherwise known as ACE. It's our fun little joke. So I oversee providing resources to the researchers across campus, trying to enable your research workflows to work more effectively on our systems, and give you an introduction to what we have available and how you might be able to utilize it to advance your research. So today I'm going to focus on the new upcoming systems that we have that are specifically designed for AI ML workflows. So ACES, I've mentioned before last year, it's been a multi-phase and built on top of FASTER, but this is a test bed system. So this is an NSF funded system. And it, like I said, was designed specifically for AI ML workflows. Our goal is to provide, consulting, guidance, and a lot of training because this is a test bed system. So we're providing new and novel hardware that is designed for AI ML workflows, but is not your traditional hardware. So it really does require a lot more assistance and collaboration with the end users to develop those workflows. So what's very unique about this hardware, this is true in both FASTER and the upcoming ACES system, is that it is built on composability. So composability is a non-traditional HPC layout. So what I have on the left, the typical HPC layout is you purchase the configuration and that's what you get. And that's how it stays unless you swap out hardware, okay? A composable layout has a composable infrastructure, okay, a composable fabric, and what you have are pools of resources. And that's what we have over here, is this composable layout. So we have pools of resources, which should be, we have our CPUs, which are on the motherboard, those are static, okay? But then we have these pools of GPUs, FPGAs, or other types of PCIe-based accelerators, okay? So the PCIe means it goes into the PCIe slot on your hardware, okay? And then we also have something very novel where we have pools of memory. And that is also a new feature that needs to be tested thoroughly. But definitely the pools of GPUs and other PCIe-based accelerators, including FPGAs. And then what you do is when you go to run your simulation, you request what you think you need for your calculation. And on the back end, it composes the resources. So if you want to run a workload that needs 2 GPUs, you request 2 GPUs and it composes it. Okay. So what this means is that you're not stuck in a single configuration. If you have something that needs 1 GPU, like if you're running on Grace, our traditional HPC system, and you only need to run with 1 GPU, the other GPU often sits idle because the resources are not available for another GPU job. With the composable infrastructure, you're not locked into that, so you just compose 1 GPU and the other ones are available. Same thing, if you need 20 GPUs composed to your node, you can request 20 GPUs. Now it still has to fit within the memory footprint on the compute node, but you can compose 20 GPUs to a single motherboard. So that's like buying a system that has 20 GPUs on the motherboard, which simplifies your coding, right? Okay, or you can distribute them, either one. So that's the beauty of the composability. So I'm going to talk just a little bit about ACES Phase 1, which we have available right now. It is available through FASTER, our composable system, with those extra components. So on ACES Phase 1, we have the Graphcore IPU. We have some FPGAs available, and we almost have the bitware also. So it's an Intel FPGAs, and then we also have Intel GPUs. This is under NDA if you're Texas A&M. You can get access to those, but it's on special request. Okay, so you can send me an email or you can send an email to help at HPRC to get access to those. And then we also have some Intel Optane SSDs, which can be used as additional memory carefully on a system because it's still going through the PCIe, so it's slower access. We recently had some training for the ACES hardware, specifically designed for the AI ML toolkit provided by Intel. This has acceleration for the Intel hardware. So in the future, when you go to do your AI ML workloads, you may not necessarily need the GPU. This is designed to accelerate on the CPU. It's also designed to work across the Intel hardware, including the upcoming Intel GPUs. Okay, so the Intel GPU that we have is a pre-release, so it's still in testing phase, but the AI ML toolkit should be available to run on the NDA Intel GPU soon. So I just wanted to mention that we have specialized software installed to help facilitate you utilizing these new and novel pieces of hardware. So we've done a lot of work with the Graphcore IPU. That's what we had access to first. This is different than the GPU. It uses intelligence processing units. So that's what's shown in the upper right-hand corner there. Okay, and they have a lot of information on their website about how it's better than this or better than that. But really, you need to get in to run your workflows on the system to see how it works on your particular workflow. And we're facilitating that with training and documentation. So on the Graphcore webpage, they show what you have to change in your TensorFlow. It mostly supports TensorFlow and PyTorch. Okay, it does support some other AI ML workflows, but it definitely supports TensorFlow and PyTorch. So they've made modifications to run on their Graphcore IPUs. And it just talks about what you need to change, the small number of changes, mostly, to get it up and running on the Graphcore IPU. And then maybe additional changes that you might need to tune it. The specific thing that's important about understanding the Graphcore IPU is that it performs the AI ML workloads once you have them ported over as efficiently, if not more efficiently, than GPUs for a lower energy footprint in general and a lower cost. Okay, so that's why we've been looking at the Graphcore IPUs. So I wanted to point out that Graphcore worked with TensorDBQ, which is developed in Ulysses Group by Levi. Thank you. So they ported it over, they did the basic things, and then they also did some tuning. So if you want to read more about that, they have a blog post on that. So we have, real world AI ML workflows that have been ported to the Graphcore IPU. We have a knowledge base on our wiki, which talks about how to get started. And I'll talk just a little bit at the end about how to get access to ACES Phase 1 if you are interested. I hope you all are. We'll have advanced tech training. This will be coming up soon. We have an IPU. I'm sorry, we actually have this one already. So we have the IPU lab, which, this one already happened. We'll have another one coming up soon. Where it just goes over the initial steps of getting on the Graphcore IPU, setting it up and running basic simulations. So to get you past that initial hurdle of just how to access it and how to run. Okay, so really all of the accelerators that we will be putting in place will be fairly standard for using an HPC system where you submit a job file and then it does everything on the backside as far as getting you to the correct node with the correct resources. But then comes the more detailed information where you have to provide it the right input, okay, the right workflow to run efficiently on the novel accelerators that we will be providing. So these are some benchmarks that we ran. I'll just focus on this one here where we're using 8, which is 16 IPUs, but 8 GPUs. And like I said, the cost and the footprint for the energy is lower here, which people online can see me pointing. So I'm gonna go back over here. So I'm gonna focus on 8 here, okay? And what you can see is that the IPU has higher throughput, okay, for the benchmarks that we ran. And this is published, so if you're interested in reading more about that, you can go to that link. Yes. Oh, 1 minute, okay. I'm almost done. All right, so the last thing here that I want to mention as far as benchmarks goes, how many people have used Horbot to run IAML workflows across nodes? So one of the things that I found that you can run into when you're running AI ML, or we found, when you're running AI ML workflows is you'll run out of memory on the motherboard, okay? You can have your 8, 16 GPUs, but if you don't have a lot of memory on the motherboard, there's a good chance you're gonna run out of real memory for your workflow. So we've also distributed, which you can do with the composable infrastructure. Okay, and we've got good scaling. So Horovod allows you to run distributed PyTorch, distributed TensorFlow. So this is just for getting onto ACES phase 1. You will need an access account. How many people know about Exceed? Okay, so Exceed was the national level resource funded by NSF for HPC across the country. It is now called Access. So if you see Access, it's Exceed. Okay, so you will need an account there, and I have a link. And then these are the resources that will be coming up in ACES phase 2. That will be directly through Access. You'll have to apply through there. And it will have Sapphire Rapids CPUs, which is up to 96 core per node. These are types of workflows that we've researched that should be supported on these accelerators. Okay, and interesting contact information that you can find about ACES and Access. Thank you.
We have time for a couple of questions.
So you're all going to sign up and start doing your AI ML workflows, right? Yes.
Lisa, do we have to, so this is different from getting an account from HPC?
Yes, so for the ACES system, registration is through Access because it is NSF funded through the Access program, testbed, yes. And if you have any trouble with that, please let me know, because they just switched over from Exceed to Access and a lot of the protocols have changed. So some of it can be a little bit confusing to begin with, but we will be here to help you onboard.
And the PI has to get an account, or students can get an account by themselves?
So there's different levels through Access, and the different levels will let graduate students get accounts by themselves, but it's very limited in what they have available to them. So for the most part, the PI is going to need to apply to get a larger allocation. So the starting one is Explore. You get a small number of, at least to get on the system. Any other questions?
Comment, I mean, it's very impressive, and obviously the ability to do distributed TensorFlow is going to be a big changer, I think.
Yes, we actually put a lot of effort. Our group put a lot of effort. The user services group put a lot of effort into getting Horovod up and running. It was not a simple thing. So that's what we're here for, is to help you design your workflows to what's available on the system and provide resources that can be tuned to what you need.
This is great stuff. Thank you, Lisa.